Hello students, myself Milan Patel, Associate Professor at LJIET Institute of Engineering and Technology. Today's topic is about fire resistance. So let's start. First of all, we will see the introduction of fire resistance. No building materials is perfectly fireproof in the building. Every building contains some materials such as furniture, clothing, eatable items, etc., which can either easily catch fire or which are vulnerable to fire. However, the endeavor of architects and engineers should be to plan, design, and construct the building in such a way that safety of occupants may be ensured to the maximum possible extent in the event of outbreak of fire in the building due to any reason whatsoever. The technical interpretation of fire safety of the building is to convey the fire resistance of buildings in terms of hours when subjected to fire of known intensity. It should have structural time intervals so that adequate protection of the occupants is afforded. Okay. A wider interpretation of fire safety may be deemed to cover the following aspects: fire prevention and reduction of number of outbreaks of fire, spread of fire both internally and externally, safe exit of any and all occupants in event of an outbreak of fire, fire extinguishing apparatus, etc. Now let's see what are the various causes of fire in the building. First cause: careless discarding of lighted ends of cigarettes, cigars, matches, and tobacco, smoking in unauthorized places, indifferent maintenance of machinery, including overloading and under or over lubricating of bearings, general indifference to cleanliness, incorrect storage of materials, faulty workmanship, and inattention to electrical installations, unapproved equipment and layout, inattention of persons concerned with inspection and patrol of the premises wider their jurisdiction, inattention of fire safety regulations, etc. So these are the various causes of fire in the building. Because of these reasons, fire is occurred in this type of structures. Now let's see what is the meaning of fire hazards. Fire safety of the building should be considered from three aspects, and protection should accordingly be provided against the following three types of fire hazards. There are various types of fire hazards. First is personal hazards. Possibility of loss or damage to life referred to as the personal hazard. The consideration of personal hazard is naturally of permanent importance and requires the provision of liberally designed and safe fireproof exits and aspects in all buildings, and particularly those having more than one story. The second type of hazard is internal hazard. Possibility of fire occurring and spreading inside the building itself, referred to as internal hazard. Internal hazard concerns damage or destruction of the building and influences directly personal hazards. The internal hazard is directly related to fire load, which in turn enables the building to be graded when considered along with the duration of the fire. The third type of hazard is exposure hazard. Possibility of fire spreading from an adjoining building or buildings or from across a street or road, referred to as exposure hazard. Exposure hazard deals with the risk of fire spreading into the building through the open air from fire in other buildings, from stocks of combustible material, etc. Okay, so these are the various types of hazards. Now, let's see what is the meaning of fire load. Fire load is the amount of heat in kilocalories which is liberated per square meter of floor area of any compartment by the conversion of contents of the building and any combustion part of the building itself. This amount of heat is used as the basis of grading of occupancies. The fire load is determined by multiplying the weight of all combustible materials by their calorific value and dividing the floor area under construction. So by this way, you can calculate the fire load by multiplying the weight of combustible material to their calorific value of material and divide it by the floor area where this type of material is there. Okay. For example, if a section of building having an area of 80 square meter has 1200 kilogram of combustible material having calorific value of 4000 kilocalorie per kilogram, the fire load can be calculated by 1200, which is the weight of combustible material, 4000, which is the calorific value of this material, and divided by 80, which is the floor area. So the fire load is 60,000 kilocalorie per meter square. So you can clearly see the unit of fire load is kilocalorie per meter square. Different materials having the same weight and same calorific value may present different hazards on account of their other properties, such as rate of ignition, then speed of burning, and liberation of dangerous fumes, etc. Materials are classified for purpose of accessing fire grading under the heading non-hazardous (NH), hazardous (H), and extra hazardous (EH) based on the following categories or characteristics. First, the explosive tendencies. Second, high inflammability. Third, liability to intensify a fire. Fourth, generation of intense heat when burning. Fifth, liability to extend the fire zone. Sixth, difficulty to extinguish. And seventh, spontaneous combustion tendencies. Okay, so these are the you can say seven characteristics by which you can grade the materials in non-hazardous, hazardous, or extra hazardous. Okay, now let's see grading of occupancies by fire load. Indian Standard IS 1641:1960 grades the fire loads in the following three classes: low fire load, moderate fire load, and high fire load. In low fire load, the fire load value is less than or equal to 2,75,000 kilocalorie per meter square. These are the occupancies of this type of fire load are the domestic buildings, hotels, boarding houses, restaurants, schools, hospitals, temples, mosques, commercial offices, factories, and workshops of non-hazardous nature. Okay, these are the occupancies of low fire load, having the fire load value less than or equal to 2,75,000 kilocalorie per meter square. The second type of class is moderate fire load, having fire load value between 2,75,000 kilocalorie per meter square to 5,50,000 kilocalorie per meter square. And the example where this type of fire load is used is retail shops, emporium, bazaars, factories, and workshops. Okay, because these have the storage of number of materials, and these materials are liable to burn. Okay, so because of that, the type of class is moderate. The next is high fire load, having fire load value between 5,50,000 kilocalorie per meter square to 11 lakh kilocalorie per meter square. The occupancies of these high fire load are godowns and the similar buildings used to use for bulk storage of non-hazardous materials and goods. Okay, so these are the area where large quantity of materials are stored, and because of that, the fire load is increases. So this type of occupancies are covered in the high fire load. Okay, now let's see the grading of structural elements by fire load. The structural elements of building are graded for fire resistance by the time for which they resist the standard fire of given time temperature grading. Okay? The time temperature grading is based on observation in actual fires. The relationship between the actual fire expressed as fire load and the standard fire is established by burning down weights of combustible material corresponding to different classes of fire loads so as to match the time temperature grading of the standard fire. Okay. From the table, you can clearly see that the different grades of fire resisting structural elements will resist the corresponding fire load as per IS 1641:1960. Okay. Thus, a structure element classified as grade 4 will successfully withstand standard fire severity and comply with other conditions for an hour. Okay. If the structure element is incorporated in a building of which the fire load gives rise to a fire equivalent in severity in the test, then the structure element should resist the building fire without failure. Okay. So you can clearly see this table in which number of grades are given, and based on grades, time in hours, which is minimum against standard fire, is given. Okay. And based on that, fire load and class of fire which the structure element can withstand is given. Okay. So in this table, you can clearly see the second column, which is time in hours, based on grade number. Okay. This is the most important factor which affects in saving the persons which are in the uh, building which is liable to fire. If the grade number one is there, there is total 6 hours of time to escape the people. Okay. After 6 hours, structural elements can fail in the building. Okay. Now let's see the grading of buildings according to fire resistance. In grading, building according to fire resistance and structural precaution provided, it has been assumed that no assistance will be forthcoming from municipal fire brigade and that no firefighting apparatus has been provided or attached to the building. National Building Code of India (SP 7, 1970) divides the building into the four types according to the fire load the building is designed to resist. Okay. Type 1 construction can resist 4 hours, okay, of fire. Type 2 construction can resist 3 hours of fire. Type 3 construction can resist 2 hours of fire. And type 4 construction can resist only 1 hour of fire without the fire brigade and fighting apparatus. Experience shows that the firefighting equipment installed in the premises, the duration of fire in building having a fire load between the 5 lakh to 11 lakh kilocalorie per meter square is usually less than 3 hours. Hence, type 1 construction prescribed for this class of buildings generally ensures sufficient protections. However, in buildings covered under Type 1, proper ventilation and provisions for escape of hot gases should be made. Also, when firefighting equipment or services of a fire brigade are available in the premises, the design should provide for immediate access from several positions also. The most satisfactory condition of a building is when it is constructed to resist a complete burnout of combustible contents without failure or collapse of the building. Okay. So this is the grading you can say. The next is characteristics of fire resisting materials, or you can say what are the points to be considered while selecting the fire resisting materials. The material should not disintegrate under the effect of great heat. The expansion of material due to heat should not be such that it leads to instability of structure of which it forms a part. The contraction of material due to sudden cooling with water during fire extinguishing process after it has been heated to a high temperature should not be rapid. Okay, so the contraction of material should not be rapid. So these are the various characteristics of fire resisting materials. Okay, now let's see the general fire safety requirements for buildings. In order that the fire hazards, personal hazard, internal hazard, or exposure hazard are minimized, IS 1641-1960 recommended that the building shall conform the following general requirements. First, all buildings, and particularly buildings having more than one story, shall be provided with liberally designed and safe fireproof exits or escapes. Okay. Second, the exits shall be so placed that they are always immediately accessible and each is capable of taking all the person on that floor as alternative escape routes may be rendered unusable and or unsafe due to fire. Okay. Third is escape routes. Escape routes should be well ventilated as person using the escapes are likely to be overcome by smoke or fumes which may enter from the fire. Okay. Fourth, doors. Fireproof doors shall conform rigidly to the fire safety requirements. Okay, the doors should be the fireproof. Next, doors. Where fire-resisting doors are employed as cutoffs or fire breaks, they shall be maintained in good working order so that they may be readily opened to allow quick escape of persons trapped in that section of the building. And also, when necessary, prompt rescue work can be expeditiously carried out. Okay. Six, electrical and or mechanical lifts. Electrical or mechanical lifts, while reliable under normal conditions, may not always be relied on for escape purposes in the event of fire, as the electrical supply to the building itself may be cut off or otherwise interrupted, or those relying on mechanical drive may not have the driving powder available. Okay, so this point is also considered in the building. Lift shafts and stairways invariably serve as flues or tunnels, thus increasing the fire by increased draughts, and their design shall be such as to reduce or avoid this possibility and consequent spread of fire. Okay, so this point is also considered. Next is false ceiling. False ceiling shall be so constructed as to prevent either total or early collapse in the event of fire so that persons underneath are not fatally trapped before they have the time to reach the exits. Okay. Ninth, to a lesser extent, the provision of clause number 8, which is the clause for false ceiling, above shall apply to a single story buildings. Whatever be the class or purpose of the building, the design and construction shall embody the fire retardant features for ceilings and the roofs. Okay, so the ceiling should have the fire retardant features in it. Okay, next is floors. Floors are required to withstand the effects of fire for the full period stated for the particular grading. Okay, as we have studied, the number of grades have the number of hours of time to escape. Okay, the design and construction of floors shall be such a standard that stand up satisfactorily against collapse and suffer negligible damage, complete stripping down, and either total or major replacement. These considerations shall also be applied to other elements of structure where necessary. Okay, the floors should be such constructed that the based on grading of the building, it should resist the fire. Okay, roofs. Roofs shall be designed and constructed to withstand effect of fire for the maximum period for the particular grading of the building, and this requires concrete or equivalent construction in the roof. It is, however, important that construction shall embody fire retardant features for roofs also. Okay. Next is basement, where basements are necessary for buildings and basements are used for storage. Provision shall be made for escape of any heat arising due to fire and for liberating and smoke which may be caused. Okay, it is essential that fire resistance of the basement shall conform to the highest order, and all columns for supporting the upper structure shall have a grading not less than laid down in types 1 to 3. Okay, so this is the important factor because there are the columns in the basement which can liable to affect into these fire hazards. Next is smoke extraction from basement. The following requirements shall be provided for smoke extraction. Unobstructed smoke extracts having direct communication with the open air shall be provided in or adjoining the external walls and in positions easily accessible for firemen in an emergency. The area smoke extracts shall be distributed as far as possible around the perimeter to encourage flow of smoke and gases where it is impracticable to provide a few large extracts. Okay. Then third, covers to the smoke extracts shall be constructed of light cast iron frame or other construction which may be readily broken by firemen in emergency and they shall be suitably marked. Okay. So by this way, the firemen can easily get into the basement and uh, do the you can say rescue operations. Okay. Wherever they pass through fire-resisting separations, smoke extracts shall be completely separated from other compartments in the building by enclosures of the appropriate grade of fire resistance. Where these are sub-basements, the position of smoke extracts from sub-basements and basements shall be suitably indicated and distributed on the external faces of the building. Okay, that's all about the various fire safety requirements for the buildings. Now, let's see the fire resistant construction. In fire resistant construction, the design should be such that the components can withstand fire as an integral member of structure for the desired period of the building. We shall consider the construction of the following components. First, wall and columns. Second, floors and roofs. Third, wall openings. Fourth, escape elements. And fifth, strong room construction. Okay, let's see all these fire resistant construction one by one, starting with walls and columns. The following points should be observed for making walls and columns fire resistant. First, masonry walls and columns should be made of thicker section so that this can resist fire for a longer time and can also act as a barrier against spread of fire to the adjoining areas. Okay. Second, in the case of solid load-bearing walls, bricks should be preferred to stones. Okay, if walls are to be made of stones, granites and limestone should be avoided. In the case of building with frame structure, RCC should be preferred to steel. Okay, if the framework is of RCC, thicker covers should be used so that the members can resist fire for a longer time. It is recommended to use 40 to 50 mm cover for columns, 35 to 40 mm cover for beams and long span slabs, and 25 mm cover for short span slabs. Okay, so cover should be the main important you can say factor in the construction of column, walls, slabs, etc. Because this reduces the intensity of fire to the reinforcement into the RCC column, wall, or beam. Because if the steel is heated, it it weakens the whole structure. Okay, so this is important factor in construction of walls and columns. If steel is used for the frame structure, the steel structure component should be properly enclosed or embedded into the concrete, terracotta, brick, gypsum, plasterboard, or any suitable material as illustrated in this figure. You can clearly see the steel bars are exactly in between the gypsum plasterboard, bricks, gypsum tiles, clay tiles, etc. Okay. Partition walls should be of fire resistant materials such as RCC, reinforced brickwork, hollow concrete blocks, burnt clay tiles, reinforced glass, asbestos cement boards, or metalless covered with cement plaster. Okay. Cavity wall construction has better fire resistance compared to the other construction of walls. All walls, whether load bearing or non load bearing, should be plastered with fire resistive mortar. Okay. So these are the various points considered while constructing walls and columns. Now let's see what are the points to be considered while constructing floors and roofs fire resistant. For better fire resistance, slab roof is preferred to sloping or pitched roofs. If it is essential to provide sloping roof, trusses should either be of RCC or of protected rigid steel with fireproof coverings. For better fire resistance, the floor should be either of RCC or of hollow tile grid floor or of concrete jack arch floor with steel joist embedded in concrete. If floor is made of timber, thicker joists at a greater spacing should be used and fire stops or barriers should be provided at suitable intervals. The flooring materials like concrete tiles, ceramic tiles, bricks, etc. are more suitable for fire resistance. If cast iron, wrought iron, cork carpet, rubber tiles, etc. are to be used, This should be protected by a covering of insulating material like ceramic tiles, plaster, terracotta, bricks, etc. Okay. Ceiling directly suspended from the floor joist should be of fire resistant materials like asbestos, cement boards, fiber boards, metal lath with plaster, etc. Okay. So these are the various points which should be considered while construction of floors and roofs in fire resistant buildings. Third is wall openings. From the point of view of fire spread, openings in the wall should be a bare minimum. Openings serve means of escape of the hot gases. Hence, this should be properly protected by suitable arrangement in case of fire. Doors and windows should be made of steel. Fire-resistant doors can be obtained by fixing steel plates to both the sides of the door to strengthen the door against the fire. Wire glass planners are preferred for windows. Rolling shutter doors should be used for garages, godowns, shops, etc. In case of timber doors, minimum thickness of door lip should be 4 centimeter and that of door frame as 8 to 10 centimeter. Okay. All escape doors should be such as to provide free circulation to the persons in the passage, lobbies, corridors, stairs, etc. and should be made of fireproofing material. Okay. Next is escape elements. All escape elements such as staircases, corridors, lobbies, entrances should be constructed of fire-resisting materials. These escape elements should be well separated from the rest of the building. Doors to this escape should be fireproof. Staircase should be located next to the outer wall and should be accessible any floor in the direction of flow towards the exit from the building. Fireproof doors to the emergency staircases should be fixed in such a way as to make them close from inside only. The lift shafts connecting various floors should be surrounded with the enclosure walls of fire-resisting materials. Okay. The lift shaft should be vented from top to permit escape of smoke and hot gases. An emergency ladder should be provided in the fire-resisting building. This ladder should be at least 90 centimeters wide, constructed of fire-resistant materials. All escape routes over roofs should be protected with railings, balusters, or parapets not less than 1 meter in height. Okay, so these are the various points to consider while constructing aspect elements in the fire resistance building. And the last is strong room construction. A strong room construction is found to be useful in case of safe deposit walls in the bank. These are the various points to be considered while construction of strong room. The walls, floors, and ceilings of strong room are made of at least 30 centimeter thick cement concrete. If thin RCC walls are used, they should be have covering of bricks, terracotta, and then suitably plastered with fire-resistant plaster. Okay, doors and windows are well anchored to concrete walls by large number of steel holdfasts longer in length. Okay, doors and windows should be fireproof. It is preferable to have double fireproof doors. Okay, windows and ventilators should be covered by special grills made of 20 steel square bars. These grills should be well fixed to concrete wall by means of long steel holdfast. Okay, so these are the various points to be considered while constructing strong room construction. Okay. Now let's see the fire extinguishing equipments. First is manual fire extinguishing equipment, fire hydrants, wet riser system, and automatic sprinkler system. Okay, these are the four fire extinguishing equipments used nowadays in the fire hazards. First is manual fire extinguishing equipment. You can clearly see this equipment in this figure. These devices are useful for extinguishing fire as soon as it starts. They are not so useful when once the fire has spread. Under this category comes the portable extinguishers of carbon dioxide type of or foam generation type, etc. Okay, so this extinguishing equipment uh, has carbon dioxide in it. Okay, the discharge from a portable fire extinguisher lasts only for a shorter duration of 20 to 120 seconds. Okay, in some cases, especially in small buildings, baskets of water, sand, and asbestos blanket may be kept ready at all times to extinguish fire. Okay, these buckets are installed at convenient location for taking care of fire of minor size. Okay, so you can use this type of extinguishers. You can use this type of you can say the buckets of water, sand, and asbestos blanket. Okay, these are the one type of manual fire extinguishing equipments. The second type of fire extinguishing equipment is fire hydrants. This is how fire hydrants looks like. These fire hydrants are provided on a ring main of 150 diameter in the ground around the building periphery. Okay, the ring main gets water from underground tank with a pressure so that available pressure at each hydrant is of the order of about 3.5 to 4 kilogram per centimeter square. This is how the water lines are designed. This type of hydrants are used by firemen to reduce the fire hazards. Okay. Next type of fire extinguishing equipment is waterizer system. The system consists of providing 100 to 150 diameter vertical GI pipes, or you can say risers, as suitable location in the building. A fire pump is used to feed water from underground tank to these pipes to ensure a pressure of 3 kilogram per centimeter square at uppermost outlet in the building. Okay. This type of pipes or outlets can be used in multi-story building for reducing the fire hazards by the firemen. Okay. And the last type of fire extinguishing equipments, which is used nowadays in number of multi-story buildings, are automatic sprinkler system. This is how automatic sprinkler system looks like. This arrangement is adopted for important structures like textile mills, paper mills, etc. The system consists of a network of pipes 20 diameter fixed to the ceiling of the room. These pipes are spaced at 3 meters center to center. Okay, you can clearly see. Heat actuated sprinkler heads are fixed to these pipes at regular interval. The pipes get supply from the header. Each sprinkler head is provided with fusible plug. Okay. In the event of fire, the fusible plug in the sprinkler nearest to the wire melts due to rise of temperature. The water gushes out of the sprinkler head. Okay. The fire is thus brought under control in the shorter period. Okay. This is called as automatic sprinkler system. So these are the four types of fire extinguishing equipments used nowadays in the building construction. Okay. That's all about today's lecture. Thank you for watching.